Good morning, class. Today we're going to look at functions. Our objective today, which you want to write down for your objectives on page 2 in your notes, is that we're going to define terms related to a function. Then we're going to determine if a relation is a function, and then we're going to evaluate that function. So I know there's not enough room to write all of that down, but please write as much of it as you can. Let's start with the definition. An ordered pair is used to locate points on a graph. It's x and y. You're familiar with this. The first coordinate in the point represents your x value, and the second coordinate represents the y value. So the x value is the horizontal axis, and the second number, the y-axis, is the vertical axis. Another definition is a relation. A relation is simply a set of ordered pairs. There are 5 ways that we're going to look at representing a function. The first is a set of ordered pairs. Now, this is the primary way that we look at a function, is a set of ordered pairs. Second, we do a mapping. We're going to do a mapping for illustration purposes only, but that's generally not how we represent a function. Table is another important method that you need to know. And the graph, of course, is important, and equation. So all of these really are important except for mapping, but we are going to show a couple of mappings. Let's say that we are given a set of ordered pairs and we want to represent them in those 4 ways. In this ordered pair, the first set, -2, -9, x represents, -2 is an x value, -9 is a y value. So if we were to create a mapping for this, we would put all the x values on the left side. Then we would map those to y values. So -9. Now I'm listing the y values. And then I just draw an arrow to indicate which x value goes with which y value. We can also do this as a table. Again, we put the x values in the x column, the y values in the y column. And of course, we can graph this. So to graph -2, -9, I go to the left, -2, and go down, -9. Okay, but I started with 2, 7. I'm not sure why I started with 2, 7. And then 0, -1. What is that? 1, 3. I'm not sure why I'm doing it in any particular order. There's -2, -9. And there is -1, -5. And we can see from this graph that this would be a linear function. So if I were to write an equation for this, now remember, equation can be written as y = mx + b. So my y-intercept is -1. My slope in this case is 4/1. So the equation that represents this is y = 4x - 1. And we're going to talk more about how to write those equations later on in the unit. Here's some more definitions for you. Domain is the set of all x values. The range is the set of y values. So if you're given a set of ordered pairs and you want to find the domain, you would list all of the x values. Notice that I put them in numerical order and not the order in which they occurred. So the domain would be -3, 0, 2, -4, 3. I just listed them in numerical order. And then the range would be 2, -4, 0, -1, 1. If you're given a graph, you should be able to find the domain. Again, you find all the x values and the y values. So our x values, if you look at u, it has an x value of -4. T has an x value of -2. V has an x value of 2, and S has a value of 3. And then we would list the y values the same way. Another definition is a function. A function is a relation such that for every x, there's one and only one y. The x cannot repeat if it's a function. So here's some examples. We're going to determine if the following are functions or not. Now, is this a function? So we have to look at our x values to see if they repeat. So we have 0, 1, 6, 7. My x values do not repeat, so therefore this is a function. In number 2, my x values are -3, -2, -1, 2. And so once again, none of the x values repeat, so it is a function as well. In 3, notice we have 0, 4, and then 0 repeats again. And when it repeats, it has a different y value. That's illegal, so that is not a function. We're on the top of page 3 of your notes. So these are not in your notes, so I just want you to kind of go through this and answer the question before I do. So would you say that this is a function or not a function? Okay, this is a function. Even though -1 shares 2 and 0, the x does not repeat. Function or not a function? Once again, this is a function. For every x value, there's a unique y value. Is this a function? Yes, even though 2 is shared by -7 and 2, for each x value, there is a unique y value. Is this a function? No, this is not a function because -3 is shared with -5 and 12. So for every x value, there's not a unique y value. This is also not a function because 4 is sharing values. Now, this looks like it's not a function because we have -1 listed twice. But if you notice, -1 the first time is going to 7, but the next time it also is going to 7. So that is a function because we just have that point listed twice. This is not a function because -2 is sharing values. Another way to find the function is to use the vertical line test. So if a vertical line intersects the graph more than once, then the graph is not a function. So looking at this first graph, so we're going to look at 3 things here: whether or not it's a function, and find the domain and the range. Okay? So is this a function? Yes, it is, because there's no place where a vertical line would touch the graph twice. The domain of this function excuse me, goes from -infinity to 5. Notice at 5 there's a closed circle. That indicates that the graph is not going any further. But on -4, notice that there's an arrow. That means that the graph continues to go. So the domain for this function is -infinity to 5. Notice that when we write this in interval notation, the -infinity always has a parenthesis, and the 5 has a bracket because it's included, because there's a closed circle there. The range are my y values. So my highest y value is 2. But then notice once again there's an arrow that tells us that that graph is going to continue to go on and on downward. So we say it's from -infinity to 2. Is this a function? Yes, this is a function. Now, this time, my domain, I'm starting at -4. X values, the smallest x value is -4, but notice there's an open circle there, meaning that the graph does not include -4. And then to the right, it goes on forever. So our domain here is 4, not included. That's why it's a parenthesis there, -4, not included, and then it goes to infinity. My range, my smallest y value is -1. Once again, it's not included because there's an open circle there, and then it goes on to infinity. This is not a function. And the reason this is not a function, if you take a vertical line and drew it at x equals 1 or x equals 2, you can see that that vertical line would touch the graph in two different places. So this is not a function. The domain for this, my smallest x value is negative infinity because the arrow at the top left indicates it's going to go on forever. My largest x value is 3, and that 3 is included. The range, the smallest y value is negative 1, and then it goes on forever. So the range goes from negative 2 to infinity. I'm sorry, I misspoke. The smallest y value is negative 2. Okay, so is this a function? Yes, this is a function. There's no place where a vertical line would hit that graph twice. The domain, because there are arrows there, the domain would be negative infinity to infinity. Now it's kind of hard to tell the range because it almost looks like there are asymptotes at negative 3 and 3, but I think it goes on forever. So I'm going to say negative infinity to infinity. Okay, once again, this is not a function because if you take a vertical line and draw a vertical line at x equals 1, you'll see that it hits the graph twice. So this is not a function. The domain, the smallest x value is 0, but the arrows indicate that it's going to go on forever to the right. So my domain is 0, excuse me, included, and then infinity. And my y values are just going to continue to grow and grow and grow. So my y values are negative infinity to infinity. This is a function because it passes the vertical line test. There's no vertical line that will hit that twice. The domain, the smallest x value, I can't really tell from here, but we'll take from negative 6 to 6. The smallest x value is negative 6. It's included. And the largest x value is positive 6. It's included. The largest y value is 6, and the smallest y value is 0. They're both included. Is this a function? No, because if you can look at the vertical line itself and see it's hitting that graph twice. So we know that this is not a function. The domain looks like it goes from negative 4 to 4. And the range from negative 4 to 4. It's a circle. Last one. So is this a function? No, it fails the vertical line test. Its domain is one value, negative 5. Its range goes from negative 2 to 6, and because there are open circles there, that's why you have parentheses on each of those. Okay? So that tells us whether or not something is a function or not a function, and find the domain and the range. Last topic is to evaluate a function. So this is function notation, f of x, and that's how we read that, f of x. It does not mean f times x. When we evaluate a function, we replace the x with the number in the function and then do the math. So here's an example. So I have f of x is equal to 2x minus 4. And I want to evaluate f of 3. Every place I see x in the function, I'm going to replace it with 3. So I get 2 times 3, which is 6, minus 4, which is 2. So f of 3 is 2. Another example, now we're evaluating negative 1. Every place we see negative 1, every place we see x, we're going to replace it with negative 1. So that gives me negative 2 times negative 1, which is negative 2 minus 4. So that is f of negative 1 is equal to negative 6. Now in the next example, don't panic because there's a variable. We're just going to replace x with a. Now, I can't do anything else to that because they're no longer like terms. So I just have to write that as 2a minus 4. That actually ended up being a little bit easier. Again, now this time we're going to do f of a minus 3. So every place we see x, we're going to replace it with a minus 3. This requires me to distribute, so I'm going to distribute the 2. Then I'm combining like terms. So my only like terms are negative 6 and negative 4. So that gives me 2a minus 10. Example 2 is similar. This is our last example. So we're doing f of negative 1. Every place we see x, we're going to replace it with negative 1. Now, if you're doing this on your calculator, what you have to remember, you have to put 2 parentheses negative 1 close parenthesis squared, or you're going to get the wrong answer. Doing it in your head, you know that negative 1 squared is positive 1. So 2 times 1 is 2, minus 1 minus 3, and then that is just negative 2. Now we're doing f of negative 3. Same thing. Every place we see x, we're going to replace it with negative 3. We have to remember that we have to do negative 3 squared first, which is positive 9. So that's 18 minus 3, which is 12. Okay, f of 2. Then f of a is going to be the same thing. Every place I see a, x, I'm going to replace it with a. There's nothing else that I could do to that because it's already simplified. The last one, we have f of a plus 1. So every place I see x, I'm going to replace it with a plus 1. Now this is going to require that I do some FOILing, I do some algebra. So I'm multiplying a plus 1. Which gives me I'm multiplying a plus 1 squared, which gives me a squared plus 2a plus 1. And now I'm going to distribute and collect like terms. So here I distribute it, and now I'm collecting like terms. Okay? And that's about as complicated as it's going to get. So let's just review right quick. What is a relation? A relation is simply a set of ordered pairs. A domain is your x value. The range is the y value. A function is a relation such that for every x there's one and only one y. We say this as f of x. The vertical line test determines whether or not a function, a graph, is a function. If a vertical line can touch the graph in 2 places, then it is not a function. Okay, so your homework, you have 2 things to do. One is complete the exit ticket on Weebly, and the second thing is to complete page 4 in your notes. So that is what you're going to finish for the rest of the morning. Have a great day. And I will, if you have any questions, raise your hand and I will be happy to help you. Buenos dias.